Okay, so I'm going to go kind of slow on this video because I know that you might have struggled. And so I'm going to talk through every single one of these. Some may be a little faster than others. But this flat out tells you use the angle sum or difference identity to find the value of each. So sine of 285 we don't know, but you break it into two angles that you do know. Okay, so I'm thinking about I don't know, 270, no, 3, do we know 300? Oh, that would only be minus 15. Okay, so just right off the bat, I'm stumped. I'm trying to think of two angles to make the 285. Okay, what about 240 and 245? Or 240 and 45. Okay, 240 plus 45 does equal 285. Both of those are on the unit circle. So now I break this into the identity, which is sine 240 cosine 45 plus sine 45 cosine 240. If you have those two flip-flopped, that's fine. It does not matter. It's the same thing, okay? Oh my gosh. Oh, there it goes. Okay, good. Now we go to our unit circle and we plug in whatever we need to plug in, okay? So the sine of 240, now I'm doing this without a unit circle, so it's going to take me a little longer. 240 is right there, and the y value right there is going to be the square root of 3 over 2, but it's going to be negative. The cosine of 45 is that. The sine of 45 is that, and the cosine down here at 240 is a negative 1/2, I believe. Okay, so it's going to look something like that, and from here we multiply. Negative root 6 over 4, and then that will be a negative root 2 over 4. So your answer, final answer, should look like that. Number 2 is sine of 75. Okay, 75 is an easy one for me to break up in my head, right? That's just 45 plus 30. Both of those are on the circle, and it's very much like that one. We're doing this with addition, so it's just going to be the same identity. Sine of 45 cosine of 30 plus, I'm going to try to stay like y'all did it, cosine of 45 sine of 30. That's probably, wait, is that what you did, or did you do sine of the other? I don't know what y'all did. I think you probably did that. And now we plug in the stuff. Even if we have these flip-flopped, guys, it doesn't matter because it's multiplication, and that's totally legal, okay? Our answer in the end will be the same. I may change it up because I may have memorized it at your age a little different than the formula I showed you on the last page, and that may be why I'm flipping it up each time. Sine of 30 is what? What is the sine of 30? 1/2? Okay. And then it's just going to be root 6 over 4, and then plus root 2 over 4. All right, and then number 3. Cosine of negative 105. Okay, so let's think about this for just a second. We need to create a negative 105, so we could either do two negative angles added together, or we could take a big angle and we could subtract something from it. Okay, what's that going to be? 60 and 45. I'm going to do negative 60 plus negative 45. Which I can write even a little bit differently. I know those two add up to it, but that's going to be really tricky when I try to break it up. So let me think about that. You know what I'm going to do? I'm actually going to not do that. I'm going to figure out where this is on the circle and write it as its positive counterpoint. So negative 105 would be about right there because that's negative 90, negative 105. So if I take 360 from 105, I'm actually getting 255. Okay, this question is asking me for the cosine of 255. These are the same. Okay, and so since they are the same, I'm going to go with that because I think it's going to be easier for me to break apart in my head, okay? So that's going to be like, I could do maybe 300 minus 45. I think I'm going to do that because I know that that is equal to 255, and I know that now I can just use the cosine subtraction identity. So cosine 300, cosine 45, plus sine 300, sine 45. And now I don't have to worry about a bunch of negatives like I was doing up here, because then there'd be negatives here and it would be weird, and no, let's not do that, okay? So this is a way better way, and now we just use our circle. So at 300, you're over here, so you match this one up here. So cosine of that is going to be 1/2. And then the sine at 300 is going to be negative root 3 over 2. And then I filled in the other ones, and now that answer, it looks like it's going to be a root 2 minus a root 6 over 4. So once you get to this part, you're home free. It's just plugging in from the circle. This is the hardest part. Obviously, it slows me down too. You have to think it through. Number 4, sine of 5 pi over 12. Okay, I already told y'all I don't like thinking about these with radians. So I would come over here and convert it to degrees. The other way, I need to flip that. Okay, times 180 over pi. Cancel, cancel. That's 6. That's 30. So I'm getting that this is really supposed to be the sine of, is that 25 degrees? Hold on. That's a 2, dummy. Okay. 150, 75. This is sine of 75 degrees. Ah, I already did that. See, number 2. And I'm done. Okay, it's number 2. It's the same thing. So converting to degrees helps out that way too. All right, number 5. This is where it gets difficult in my opinion. Use a double angle identity to find the exact value. So this is like the very last one I did on the video. It's telling me that the cosine of some angle is negative 4/5, and then it gives me this criteria right here. Now, in the video, I said quadrant 1, quadrant 2, quadrant 3, quadrant 4. You get to figure this out, everybody, but you can, right? Because pi is here. 3 pi over 2 is here. So if you're in between these two, you are in quadrant 3. Okay? So this is a fancy way of saying I'm in quadrant 3. So what I'm going to do is draw my picture and draw like something in quadrant 3. I need to make a triangle out of that to the x-axis, and then I stick my angle by the origin. So I'm inside this triangle. Now cosine is x over r. Or, if you don't like x over r, it's adjacent over hypotenuse. So either way, there's a 4 here, there's a 5 here. Now where does that negative go? Well, it goes up here because my x is always negative in quadrant 3. And just so we're clear, when I find my y in just a minute, I'm going to put a negative on that also because we're in quadrant 3. Now the radius cannot be negative, so that's why there's just a 5 there. Alright, now this is a 3, 4, 5 triangle, so either you know that or you do Pythagorean theorem. And now we find whatever it wants, which in this problem is the cosine of 2 theta. So when you look at your definitions, like you have all these choices of things to do. So I'm going to choose a different one just for funsies. Let me choose 2 cosine squared theta minus 1. That's one of them that's listed. And the reason I'm going to choose that one is because I already have this, right? Like it was given to me above. So I'm going to do 2 of these squared and then minus 1. So that's a 16/25. And when I do that math, that's a 32/25. And then that's going to be a 7/25 once I put those together. Now, if you chose something else, that's fine, guys. The math will work out to be the same thing. So if you chose the one that was in the last video, because I'm guessing you might have since that's how I did the example, you would have just been doing 1 minus 2 times sine would be negative 3/5 squared. And that would be 1 minus 18/25, still 7/25. Okay? All right, let's move on. Number 6. So I'm going to look at what quadrant I'm in first, okay? Out to the side, it says I'm between 180 and 270. So I'm over here again. Let me draw my triangle. Let me stick my angle in. I know that the sine is negative 3/5. Okay, so what is sine? Sine is opposite over hypotenuse, or y over r. And that's got to be a negative, okay? It wants to know the tangent of 2 theta. We have not done one of these yet. We haven't even looked at that formula. So I'm going to have to pull that formula up here in just a second. Let me find this missing side first. Negative 4, right? We're in quadrant 3. They're both negative. So now we need to look for a formula for this. So look back at your page if you haven't done this one already. I'm actually looking back. This is one that I don't have memorized. So it's 2 tangent over 1 minus tan squared. Okay, so it's 2 tangent over 1 minus tan squared. Okay, so basically I need the normal tangent, then I'm going to plug it in everywhere. So tangent of an angle is when you are the y over the x or the opposite over the adjacent. So it's going to be negative 3 over negative 4, which is 3/4. So 2 times 3/4 over 1 minus 3/4 squared. And you're going to math that out. So that's going to be 3/2 over, let's see, that's a 9/16. So what's 1 minus 9/16? 7/16? 16 minus 9. Yeah, that works. Okay, and then you fix this fraction, right? So this would be 3/2 times 16/7. So that would be 24 over 7. Okay, I'm getting 24 over 7. Feel pretty good about that. If you think I did it wrong, email me. I know I did my arithmetic kind of quick right there, but feeling good about it. All right, so there was number 6. That's probably one of the harder ones on the whole page. Okay, this next one, we are between 3 pi over 2 and 2 pi, which means we're over here. So I'm going to draw a little random ray or whatever, and then I'm going to pull it up to the x-axis and stick my angle on the inside of the triangle. Okay, the cosine is 4/5. So the cosine is adjacent over hypotenuse, or x over r. And is that neat? And it's positive because of the quadrant we're in. Now, the sign is going to be negative. So if you found that that was a 3 and you forgot your negative, please go stick that back on, because look where you're located. You're in quadrant 4. Y is negative in quadrant 4. Now it wants the cosine of 2 theta. So once again, use whatever formula you want. Well, I'm going to just use, I don't know, let me use the other one just to show you that it works. Cosine squared minus sine squared. And so I'm going to find the cosine, which the cosine of this is just 4/5 squared minus, and now the sine would be negative 3/5 squared. And so that would be 16 over 25 minus 9 over 25, and it's 7 over 25. All right, so I'm getting 7 over 25 for that one. All right, cool. Number 8. So same thing, except for this one I'm in quadrant 1. All right, which means everybody's positive. So this is a little bit easier because everybody's positive. The reason this one's not easier is look at those numbers. The cosine is the square root of 7 over 4, which means that's where those are located. I do need to do the Pythagorean theorem to figure out what in the world that's going to be. So this is b squared equals 9. Oh, it's 3. Is it really just a 3? That's pretty easy. It is. Awesome. Okay, so just do your Pythagorean theorem and you'll get that. Now what does it want? It wants the sine of 2 theta. Okay, well sine is the formula 2 sine cosine. And so if it wants 2 sine cosine, I'm just looking at that formula, guys. Bring down the 2, and then I need to fill these in with what are the sine and what are the cosine. So the sine of this picture is 3/4, and the cosine is root 7 over 4. And then I just do the math. So this will be a 6 root 7, right? I'm just doing top times top times top over bottom times bottom times bottom. Oh, I could reduce that. I just saw that they were both even. So that would actually be 3 root 7 over 8. That's probably a better answer. Okay, cool. Now, the last two, for a lot of people, are the hardest because there's no rules other than just try to make it look better by plugging in whatever you want. And so you might have been like, what? Okay, so on this one, I told you guys I try to leave sine and cosine alone and then just plug in for the other one. So if you look at your sheet, tangent is sine over cosine, and then I recopy the rest. Okay, look at this, right? This cosine could really be over 1, and we could go boom, boom, and cancel those. So this is just sine x plus sine x. And doesn't that mean there's just 2 of them? So that's how I would do that, and I would quit right there. I can't see it getting any prettier than that or doing it any different way to make it better. Simplify the following expression using Pythagorean. Okay, they kind of gave you a hint. If they're saying Pythagorean, they're saying that they want something to be squared eventually, okay? So based on that, I mean, look at this problem. This is kind of like the one I did in notes. Immediately you should think FOIL, and when you do, you're going to get that when you FOIL. Now, if you look at this and you look at all those formulas on your paper, there is a formula for this, and it says that it equals sine squared of y. And so that would be your answer. You can replace all of this with that because that's like exactly what it says. It says, I don't know what letter it used. I think it used an x. So it said sine squared of x equals 1 minus cosine squared of x. So if you see that, you can replace it with that, and that's what I just did. All of that was there, so I replaced it with that, and that's the final answer. All right. Fun, wasn't it? Okay, so we will definitely work more on this in tutorials. And like I said, if it's frustrating, that's okay. It is for everybody, and you will get better with time and practice.